In this video, we'll discuss more examples about how do we use L'Hopital's rule to evaluate some limit. And recall that L'Hopital's rules deal with 0 over 0 or infinity over infinity, right? Whenever you have a fraction, both numerator and denominator goes to 0, or both go to infinity or negative infinity, we can apply L'Hopital's rule. So let's see the example 1 here. We are looking for this limit as x goes to 1 natural log of x minus 1, right? So that's an easy fraction, right? Now you can see that as x goes to 1, natural log of x goes to natural log of 1 because this function is continuous, 1 is in the domain, so this is 0, right? X minus 1 also equal to 0, right? So this is what? This is 0 over 0, right? So if you have 0 over 0, if the derivative of f prime over g prime exists, this will equal to that. So all our calculation will show whether f prime over g prime, the limit exists, right? So apply the L'Hopital rule. This is same as x goes to 1, the derivative, the numerator, which is 1x, the natural log of x, derivative is 1x. So 1 minus 0, derivative x is 1, derivative 0 is 0, right? So this is same as x goes to 1, 1x. Now we are ready to plug in 1 because if you plug in 1, you don't have 0 in the denominator anymore. So this is 1 over 1. This function is continuous. This function is continuous. 1 is in the domain, plug in 1. So this is 1, right? Okay, now let's see another example, second example. As x goes to 0, x squared over 1 minus cosine of x. So this is, okay, let's see that, right? If you plug in 0, right, I can see that as x goes to 0, x squared goes to 0 squared, which is 0. 1 minus cosine of x goes to 1 minus cosine of 0. Cosine of 0 is 1, so this is 0. So this is, again, a 0 over 0 kind of limit. We can apply the L'Hopital's rule. So this is same as x goes to 0, 2x over what? Over 0 minus negative sine of x, right? The derivative of cosine is negative sine, right? So this is equal to the limit as x goes to 0, 2x over sine of x. Now, if you plug in 0, you still have 0 over 0, right? Sine of 0 is 0, 2x 0, 0. So let's try our rule here one more time. So this is as x goes to 0, 2 over cosine of x. Now, if you plug 0 into the denominator, you get cosine of 0, which is 1, right? You don't have 0 anymore, so this is 2. Right? 2 over 1, which is 2. So the limit is 2. So sometimes we do have to apply L'Hopital's rule more than once. Okay. So let's introduce one more, right, indeterminate form, which is 0 times infinity, right? Indeterminate form 0 times infinity, right? So this is basically the limit in the form as x goes, that's a product form, right? X goes to some number, a could be positive infinity, negative infinity, one-sided limit, right? A plus, a minus, right? So any possible variation, right? F of x times g of x. So as x goes to a, f of x goes to 0, g of x goes to infinity or negative infinity, right? Doesn't matter if positive or negative. You can switch them or just multiply negative one in front. Everything will go from positive to negative. Okay, so this is indeterminate, right? 0 over infinity is 0, but 0 times infinity could be anything. So strategy here is for sure we want to use the L'Hopital's rule, right? So if strategy here is we want to change our product to a quotient. So change our f(x) times g of x to f of x over 1 over g of x. This give you a 0 over 0. Or sometimes it works better to g of x over 1 over f of x. So 1 over 0, right? 1 over something goes to 0 for sure. We know that's either positive or negative infinity. So this is infinity over infinity, right? Do either of these. Sometimes one works, the other one doesn't, and depends on the function form. So yeah, and this is based on the problem function form, right? We don't have a good rule for that. Let's see an example. We are looking for the limit as x goes to 0 on the right side, natural log of x times sine of x. Okay. So as x go to 0, on the right side, natural log of x, we know that's because x equal to 0 is the horizontal asymptote of y equal to natural log of x. So this one actually goes to negative infinity. If you recall the graph of y equal to natural log of x, the graph look like this, right? So this is 1 here. And sine of x goes to sine of 0, which is 0. So this is infinity times 0, or 0 times infinity. Order is commutative, right? Order doesn't matter. So we want to change it to fractions. So this is same as x goes to 0 on the right side, natural log of x over 1 over sine of x. Right? And now after you change from a quotient to a what? To a product to a quotient, right? This goes to 0 positively, right? So this is basically infinity over infinity, not equal, right? Then we can apply our L'Hopital's rule. So this is same as x goes 0 from right side, 1x over negative sine of x and negative 2 times cosine of x. And now we want to simplify the function form, right? So this is same as x goes to 0 on the right side, you get negative cosine of x. No, not cosine of x. Numerator should be what? Should be sine of x squared, right? Sine of x squared over x cosine of x. Now, if you plug in 0, you get 0 over 0, right? Sine of 0 is 0, cosine of 0 is 1, x is 0, 0 times 1 is 0, right? So now we differentiate this one more time. As x goes 0 on the right side, 2 times sine of x cosine of x. Cosine of x plus x times negative sine of x. So that's basically the duality of this function, right? Now if you plug in 0, numerator is still 0 because sine of 0 is 0. Denominator now is 1, right? Cosine of 0 is 1. X times sine of 0 is 0. So 0 over 1, so this is 0. So that's our final answer. The limit of this indeterminate product is basically 0.